Welcome to Ask and Learn.
All right, let's go ahead and answer this question. So the question is we have a quintic x to the fifth minus x cubed plus 2, and then it is limited between the region -1 to 1. The question is graph it and approximate the maximum and the minimum value. And the other part is use calculus and what you've learned to precisely locate the exact value of the maximum and the minimum. So as usual, because the region is limited, we need to keep in mind the extreme value theorem, saying that if a maximum or a minimum occurs, we have to check the minimum and the maximum value, not the minimum and maximum, excuse me, the endpoints, -1 and 1. So we're going to check what f of 1 and f of -1 are going to be. Okay, if you plug in these numbers, you can see that the -1 minus -1 cancels each other out, so you will get a 2, and the same thing happens when you plug in a 1. Okay, 1 minus 1 is 0, so f of 1 and f of -1 are both 2. Okay, so it's neither a maximum or a minimum right away, because we know that this is not a straight line. Okay, so we're gonna now take a look at the critical points. If the derivative is equal to 0, we know that those points are likely to be a maximum or a minimum. And this is a polynomial with odd powers. So we know that we're not going to be dealing with a situation where um, the maximum and the minimum bounces off the x-axis and such. So it's highly likely that it's not a saddle, but we got to check it anyways, okay? So first, let's take a look at the graph. I already graphed it for you. X cubed minus x to the fifth minus x cubed plus 2 is given right there. And to make it look a little bit better, x equals to -1 to 1. When I do this, oh, -1 to +1. I know that it is this region to that region that I'm focusing on. So the maximum value happens somewhere around here. Let's see if I can, oh, I can. Maybe around there. So it seems like 2.186 or so is going to be my maximum. The minimum here is 1.814. So let's see if we can get those two numbers. And as you can see, it's indicating that it's symmetric. So possibly the solution is going to be um, a plus or minus something kind of number, where if we plugged it in, we get these heights. Okay, so that's one thing that we could observe. All right, so let's go ahead and try to do this analytically. So we're going to find the derivative first. This one shouldn't be that big of a deal by now. F prime of x is 5x to the fourth minus 3x squared. 2 just becomes 0. We're going to let this equal to 0. So x equals to 0 is of course going to be a saddle. As we saw over here, it decreases but decreases again, so it's not a critical point. So it actually did show up. My bad, before the explanation that I made. So I factored out an x squared and did that calculation. What's the other part? It is going to be plus or minus the square root of 3/5. So those are the critical points. If you take a look, you can see that it's going to give you a maximum here, a minimum there. If we started off with the analytic process, I could have probably found the second derivative, plug these numbers to see if it's going to be positive or negative. Because if you get a positive second derivative, we know that we will end up having a minimum because it's concave up, and vice versa. If it's concave down, it's a maximum. Okay? Moving on. So we don't want to end here. We want to actually find the maximum and minimum, not where it's located at. So we're going to plug in these two numbers into f. So I am only going to do the case where it's the square root of 3/5, just to show you the trick of what we can do to make the process a little bit simpler. Okay, so if we plug this number in, we can do the calculation, of course, but to make it simpler, you can see that I can factor out an x cubed from both of these expressions. So x cubed times x squared minus 1 plus 2. Why did I do that? Well, x squared is a nice number. It's 3/5, right? So this expression right here, inside the parentheses, it's 3/5 minus 1, which is negative 2/5. X cubed is also not that difficult to calculate because I know that x squared is 2/5. I meant 3/5, so this is 3/5 square root of 3/5. So if I go through the calculation, it is going to simplify to negative 6/25, the square root of 3/5. I am not going to rationalize the denominator because to me this honestly looks simple enough, okay? Plus 2, and this is the expression that you will get over here, okay? If you plug in f of negative cube, the square root of 3/5, it has to go all the way there. You will get the positive version of this expression, plus 2. Okay? And then these are going to be the precise location of the maximum and the minimum. And then you can see that if you plug it in a calculator, it will actually be these two numbers that you see right there. Okay? And this is how you solve this problem.